3 more units and that's it. We will be done learning right around spring break. This next unit is 19 and 20. I can teach all of 19 in about 20 minutes, so we're going to do that next. 20 is a day and a half-ish. Our next unit after that is trends, like why is the radius smaller? And then our next unit after that is solids and intermolecular forces, so we are done with like equilibrium math. That does not mean that we aren't going to keep doing equilibrium math because we cannot forget how to do it. So our warm-ups are going to be more like, going to be more like today where it's like, okay, now we know enough to actually do some problems and get used to the words. Okay? Entropy is the dispersal of matter and energy to increase the randomness in a system. System surroundings, remember that. The system is just the chemistry, like the molecules doing their things. We are the surroundings. So enthalpy was the heat part of the system and surroundings. Entropy is the wiggliness, okay? So like right now, aside from Jordan, you guys have low entropy. You're sitting in rows, you're not really moving, maybe you're vibrating a little because you're writing. Come to resource or stay for resource. And the freshmen, and then sometimes the sophomores come. And if you guys come for help, right, that's high entropy. A lot of disorder. The freshmen are always moving. Maybe they're throwing something, but that would be an increase in entropy. Right, eating IDs. The letter for entropy is S. If we increase the entropy, it's a positive S. If we decrease it, it would be a negative S. Okay? The way I know is I'm going to look at 2 different things. I'm going to either look at the matter, so meaning solid to a liquid to a gas. That would all increase my entropy. Solids are like you guys. Liquids are like the freshmen. Like they're just kind of milling around, moving around. Gas would be like the field house filled with lots of people for like a basketball game or something, like high entropy. I can also look at the number of moles. If I increase the number of moles, I have an increase in entropy, and that's just because there's more stuff. Second hour before you has a full class. They just have increase in entropy because there's more people, even though everybody was sitting in their desk learning, okay? And then if I'm talking about gases, if I have a bigger volume, I'm automatically going to have more entropy just because they have more room to walk around it, okay? So even if I took the freshmen the same amount out of this room and took them to the field house, just because there's more room, they're going to have more entropy. If I increase my temperature, I have more kinetic energy. More kinetic energy would make sense then to have a higher entropy, okay? When the music starts, please talk to somebody about what entropy is, and then 1, 2, 3, 4 ways to increase it. Okay, ready? Go. Law of thermodynamics says the entropy of the universe is increasing. Increasing entropy is favorable, meaning the kids don't want to sit in their desk, the kids want to party. So over time, the entropy of the universe is increasing. Spontaneous means that the reaction is going to happen with no outside force. In other words, K is greater than 1. I do not know why, but in entropy, we don't worry about K is greater than 1. We just say K is greater than 1. So if K is greater than 1, it lies right. I made these products. Look, I mixed these things together and I made something new. Spontaneous just means that it happened without an outside force. Non-spontaneous is the reverse reaction. That means my K is less than 1. It lies left. I mix it together and nothing happened. Okay? The only time in your whole entire life that you're going to see this phrase, thermodynamically favored, is on the AP Chem exam. Some writer decided that you wouldn't understand the word spontaneous, so they changed it to thermodynamically favored. In any textbook and anything you ever have to do with chemistry the rest of your life, if you want to, they will use the word spontaneous. I'm going to teach it to you like spontaneous, but I'm just going to remind you. Don't forget, on the AP exam, the words are going to say thermodynamically favored. You don't have to use those words, but in the words and the writing, it will. Spontaneous does not mean rate. Dinosaur poop turns into diamonds. It's spontaneous. It's like K is like times 10 to the 47th. Like it's huge. It's just really slow. The reverse reaction is non-spontaneous. I cannot turn diamonds back into dinosaur poop. No matter how long I wait, it's not going to happen. Okay? It'd be nice, but we can't. I think it'd be fun to risk. Okay, so when the music starts, can you please talk about spontaneous and non-spontaneous? They thought that you'd think spontaneous means fast, so they changed the word. Spontaneous is not real. When the equilibrium lies left, that means I have lots of products. I did not make anything new. Nothing has happened. If my K is greater than 1, I have lots of products. Look at, not reactants. Look at all the products I made something new. It happened and I didn't have to do anything. I mixed them and it's like, ooh, it made bubbles. We pick reactions that have a fast rate so our eyeballs can see them. There are a lot of reactions that have a K greater than 1 that are just really slow. So when our eyeballs look at it, it's like nothing's really happening. It doesn't mean it's not going to happen. Spontaneous just means it does not have anything to do with rate. It's not saying fast or slow. That's called kinetics. It's just saying it will happen. The letters for spontaneous and non-spontaneous are G. And G stands for Gibbs free energy. Gibb is a guy. If it's a negative delta G, that means it's going to be spontaneous. It's going to happen. The K is greater than 1. That means the kids got to party. And it also means that heat was released from the system. I did not have to put heat in to get it to go. Non-spontaneous is a positive delta G. It means the kids had to sit down. And I had to put heat energy into it to get it to go. My K is going to be less than 1. My equilibrium is going to lie left. And this is going to be right. The letter is G for spontaneous. The letter is S for entropy. I added in some enthalpies, so please talk about that. Remind yourself what H is. Ready, go. We can math G. Delta G equals delta H minus T delta S. Not like an equation you ever have to remember. You have an equation too. Remember, if it's negative, that means it's spontaneous. If it's positive, that means it's non-spontaneous. That means my K is less than 1. This means my K is 3. The problem with this, the challenge with this, is you got to make sure your units are right. The right units is going to be kilojoules. The problem is entropy is measured in joules. So we're going to pull numbers off a camel, but the numbers are going to be in joules. We have to convert it to kilojoules in order to use it. Temperature has to be in Kelvin, and your camel enthalpy already is in kilojoules. If I have a negative delta H, that means heat left the system, and my entropy went up. The kids got to party. I know for sure it's going to be spontaneous. That means that I'm going to have a negative delta G. If I have to put heat into the system, like I put it on a hot plate, and the kids have to sit down, then it's going to for sure be non-spontaneous. I'm going to have a positive delta G. It's those in-between situations that we're going to have to math to figure out, okay? If I have, I put heat in, but the kids do get to party, it's only going to be spontaneous at high enough temperatures. Because math, if this is my equation, my temperature is going to multiply my S. So if this number is bigger than this number, then my delta G is going to be negative. One way I can make this number bigger is to multiply it by a big temperature. The hotter it is, the bigger this is, so more likely it's going to be negative. Make this 20. So 10 minus 20 is a negative 10. Negative means spontaneous. This is only going to be spontaneous at low temperatures. I need to make sure this stays smaller than this. Okay? When the music starts, can you please talk about why temperature matters? I'm making this number bigger or smaller than this number to decide if this is going to be positive or negative. Ready? Go. Okay. Ice melting is a really good example of that in-between. Going from a solid to a liquid means I have to put heat into it, into the system, get it moving. But going from a solid to a liquid means the kids get to party. So this is happy, this is sad, so now temperature matters. Delta G equals delta H minus T delta S. If my temperature is high enough, then my delta G is going to be negative. If the temperature is above 32 degrees Fahrenheit, guess what? The ice is going to melt. I don't have to do anything about it. It's spontaneous. If I take an ice cube and put it on my table, and even though it's super cold in here, it's still above freezing, surprisingly, it's going to melt. Like there's nothing I can do. And it's non-spontaneous. I can't make it turn back into ice if my temperature is too high. Okay? I can sit here for eternity. It will never turn back into ice as long as it's 60 degrees in here. That's non-spontaneous. Okay? So these in-betweeny ones we will math just to make sure it stays negative or it turns positive. The temperature matters. Talk about ice melting real quick, and then we're going to talk a little bit more math. Where'd you go? This image goes here. I don't know why it's up there, sorry. I didn't look at it before I sent it to get printed, obviously. That goes with this driving non-spontaneous. The relationship from between delta G and K. So we know a negative delta G means it's going to be K is greater than 1. It lies right. Look at, I made product. If, I'm sorry, I said that backward. That's a negative delta G. That's spontaneous. A positive delta G means it lies left. Nothing has happened, non-spontaneous. I can solve, though, to figure out what exactly my K is. Delta G equals negative rattling. negative rattling is how we are going to convert between G and K. So I know K is going to be greater than 1, but like, what is the value of it? Okay? The R is not gas R, it's joule R, 8.3145. Gas R, 0.08206 is only for gases. T, temperature in Kelvin, Ln is called the natural log. Its base is E. Second natural log gives you a little E. K has to be in joules. This also has to be in joules. Okay, so let's say something is non-spontaneous. That graph is supposed to be here. How do we get it to go? They want you to know two things. You can either give it energy, that means plug it in, or put it in the sun. Photosynthesis is a non-spontaneous reaction if it's not in the sun. A plant does not grow in the dark. It will not produce oxygen. The sun forces, those are real words, driving, it drives the reaction. Reaction coupling means that step 1 of the reaction releases energy to make step 2 go. Releases energy to make step 3 go. If you've taken AP Bio, it's called oxidative phosphorylation. It's the electron transport chain, turning ADP into ATP. Uses reaction coupling, and I'm using that example specifically because it's in my learning objectives. Photosynthesis is non-spontaneous. Plants don't grow in the dark unless there's light. Okay? We are going to do some sample problems, so can you page it to the chapter 19? That was all of 19. Done and done. Let's do a couple of sample problems, though. Okay, good.
That's the only thing I was worried about.
All I needed to say was the ice thing.
No, all you have to say is what it's.
Got it.
Well, because not for people you have to do something else. Yeah.
I can drive it by plugging it in, giving it electricity or light, or reaction coupling. I know, I wonder if you should, that could be like your research project. You can do it for it. Okay, predict the sign of the entropy change is asking you to decide if it's going to be a positive delta S. That means the kids get to party, or if it's going to be a negative delta S. And then for number 2, it's asking you to pick which one would be the biggest positive delta S. So can you please do those two we can battle with? Calculate the standard free energy change. Those are words for G. For the formation, words, balanced equation. So I'm given my H and my S. So I know my G equation is not going to be rattling because I don't have K. I have delta H minus T delta S. The biggest challenge for these kind of math is just make sure our units match. We don't want to put different units in. So delta G equals delta H. I'm going to make sure they're both kilojoules. My delta H is kilojoules. Minus T, temperature, Kelvin, 298, times my delta S, but it's in the wrong unit. It always will be. You're going to have to convert it to kilojoules. That's a scoochie back 3 situation, 1, 2, 3. So 0.0247. Okay? It's just going to be some button pushing. We don't even really have to do algebra for this, but we will find out if it's going to be positive or negative. Go ahead and push your buttons. 173. Positive delta G means it's non-spontaneous. If I wanted to, I could calculate my K. It'd be less than 1. My equilibrium lies to the left. Look at these reactants that nothing happened to. Okay, let's do 10, because 10 is rattling math. And rattling math just has different maths. Okay, the standard free energy change for the Haber, remember Haber process? It's making ammonia. Is given here. So standard free energy change is G. So they gave us G. Calculate the equilibrium constant. Those are words for K. So I'm solving for K. My only G to K equation is rattling. Negative rattling. This is going to involve some algebra. I have my G. Fancy R is in joules. Fancy R is in joules, so that means my G has to be in joules. That's a scoochy forward 3. 1, 2, 3. Negative 3, 3, 3, 0, 0. I know that because fancy R is in joules. And I know that because I have an equation sheet and I'm double checking. Equals negative R 8.3145 times my temperature, 298, the natural log of K. I'm solving for K. So like to 7th grade algebra this, I would take my negative 33 number divided by this. And then to undo a natural log is a button. Second natural log is E. I'm right up here. So you end up with E to the 13.44. Did you get that? Okay. Now we would have expected that because delta G is negative. So we knew it was going to be greater than 1. And it's pretty big. The other math problems are pulling numbers off of CAML. CAML is when we do products minus reactants, we multiply it, but we've done that before. So, your homework is on the worksheet, just the first page, especially if you're having trouble figuring out if kids are partying or not. The front side is like, is it going to increase? Is it going to decrease? The back side is